Please don't touch now. So the compulsory question for us in an examination is concentration of electrons in conduction band. This is the question. So derive the expression for the concentration of electrons. Concentration of electrons in the conduction band. So this is one of the compulsory questions. You remember when the electrons are going from the valency band to the conduction band, they are leaving a hole in the valency band. Right? So if they want to ask you, what they will ask you is what is the hole concentration in the valency band. But in the conduction band, it is always electrons. So concentration of electrons in the conduction band, which means how many number of electrons are there in conduction band. So to start with, at T is equal to 0. What happens? Are there any electrons in the conduction band? No electrons are there. So you need to write at T is equal to 0, your conduction band is empty. To have the conduction band, you need to apply the temperature. When the conduction band is empty, your valency band is actually completely filled. Or the filled. This is the scenario at temperature T is equal to 0. But to get the electrons, you need to apply temperature greater than 0. This is very much needed. Any conduction to take place, you need to give the thermal energy. So at T greater than 0, what happens? Electrons, they leave valency band and goes to conduction band. Now I am asking how many electrons are going? I provided some temperature. How many electrons are going? Then depending on my need, I can increase my temperature, then more number of electrons can. So I need to have some number in terms of temperature, so that I can tune my temperature and control the number of electrons that are going. That is what engineering means. We are actually engineering the device. For that you need to have some parameters in your hand. So let us understand how many number of electrons are there. It is like asking population. How do we usually get the population? If I ask how many number of students are there in section B8, how do we get that information? You might say 70, but how you got that 70?
By counting.
Counting 1, 2, 3 like that? No man. Counting I can count 80, 90 also now. I stopped at 70. Why? How many? It's not present. If 70 are there, if they are absent, how do you know? What defines you?
Your presence.
Okay, forget. Let me even more precisely ask you. How many males are there? How many males? Male. You don't have confusion now? Because you are looking like that. No confusion. So, how do you know? Out of the 70, if I ask how many number of male candidates are there, how do you know? There is no probability. Hello? Arey man, you should know what is male, right? Unless you know, you cannot count. So you are applying a condition. That's what I mean to say. You are applying a condition. Okay, these characteristics refers to a male. So you are applying a condition saying that out of 77, okay, other people belongs to female section because their characteristics are different. Rest of the people are male. That's all. So first you are taking 77 as a whole, that is the number. Then you are applying a function or a condition. Okay. Same thing we will do. So how B8 formed? Same thing. Total number of students are there in CED. Some 1,000 people might have joined here. Out of those 1,000, what is BH section? Those people with particular rank or something, some function they apply. So that they segregated these only 70 people here. Similarly, now you are asking how many number of electrons are there. You need to also have some kind of function. How many total number of electrons are there? How many can go? That function needs to be there. So how do you know? How do you get is, this is the function. So electron concentration, if you want to define, let me define it as concentration of electrons in conduction band, let me call it is given by small n number of electrons in the conduction band. So Nc is given by how many number of electrons are there, n of E, and not every electron can come. Not every people can be counted as a male. You need to have some function again, f of E, where you are looking at everywhere in the space. So I say it is under minus infinity to infinity. Total number of electrons are there. Then you are applying a condition. The number of electrons satisfying this condition will only be your actual number. That's the same logic we are applying. So what is n of E here? Here n of E is nothing but number of electrons per unit volume. N of E is nothing but number of electrons per unit volume. Okay. So total number of electrons you can, but all of them cannot go. So you applied a condition or a function called f of E. This is called Fermi function. And in the next class we will talk more details about what is Fermi energy, Fermi level, Fermi factor. But now you take it as a Fermi factor or Fermi function. F of E is basically the probability. What is the probability? You are defining a probability that certain number of electrons can go there. Why they are going? By applying the temperature. What's the probability you need to know? So it is like asking what is the probability that he is a male candidate. Probability is 1. So I counted him. If I have a doubt on some person, the probability is 0.5, something like that. No? Like, so what is the total number of electrons are there? What is the probability? You have to know. So those probability you have to take. So out of n available number of electrons, those who satisfy this condition only can go to the conduction band. So f of E is the probability that any electron can occupy the conduction band. Probability that a quantum state is occupied by an electron. That electron goes to conduction band. I wrote it in more specific way. The probability can be applied anywhere. So now, but you know that this is from our knowledge. What we are saying is n of E is this is other words also called density of states. This also has a name called density of states. Density of states. We are not deriving, actually there is a derivation for the density of states. But we are taking the direct equation. N of E is equal to 4 pi by h cube into 4 pi by h cube into, this is what we know, 2 m star into e power 1 by 2. 2 m star to the power 3 by 2 into e power 1 by 2. This is density of states or n of E, or else the number of electrons per unit. So this we did not derive, we are simply taking it. Okay. In the syllabus you don't have the derivation, but you should know what is density of state. It is the density of the electrons per volume. What is density? Mass by volume. Same thing now. Mass by volume. Mass is nothing but how many atoms, number of electrons per volume. Mass by volume. That is the density. So this is density of state. State is nothing but how many electrons can be there in that limit. What is the limit? Now you are looking at minus infinity to infinity broadly. So what is ME? Mass of the electron. Why star is sitting there? Because there will be slight change in the mass when you apply electric field. When the conduction is happening, mass won't be exactly 9.1 into 10 power minus 31. So this is called reduced mass or the effective mass. Slight variation is there. So that's why star is considered. So ME star is the effective mass of an electron. So E is energy. Okay. So how many number of electrons can stay with this energy is given by this enough. Right. So now the probability also you have to write. Probability or the Fermi factor is can be written as f of E is equal to 1 by 1 plus exponential of E minus Cf by kT. That's the probability. Look, what we are doing here is you are applying temperature T. See here, as long as your temperature is 0, electron need not to go. It cannot go to the conduction band. So you are giving temperature T. If you tune T, depending on the temperature, electrons can go. So that's the probability that we are taking. Okay, I am applying this much temperature. What is the probability that electron can go? That's what you are asking. So here temperature is coming. These many are there, but you know you are heating with this temperature. How many can go? That is the actual number. Now you got it. So this is my probability for. Substitute that in this equation number 1. Then we will get N of C is. If anything is not clear, please ask me. Substitute that. Yeah. E minus Ef by kT. E is the energy state. Ef is called Fermi energy. Ef is called Fermi energy. Fermi energy. So you need to know what is the Fermi energy. When T is equal to 0, all the electrons are in the valency band. Okay. So this is called your Fermi function. That is Fermi function. In a pure semiconductor, if you take, if this is your conduction band and if this is your valency band, this is your energy of conduction band, energy of valency band. Just now we discussed that. Now your Fermi energy is an imaginary energy. Let us take Ef. It lies there, which means at T is equal to 0, you will be understanding that all electrons are below Fermi energy. It is a reference energy for you to understand. So all the electrons are where? All the electrons below Fermi energy. But if T greater than 0, what happens? Electrons are going above Fermi energy. It's not? They are crossing it and going above Fermi energy. So your energy levels are with reference to Ef you are talking, whether you are down or up. So that is the usage of Fermi energy, Ef. Okay. So let us substitute the values. K is, you know the K, right? What is K? Boltzmann constant. D is the temperature. So let us substitute. N of C is equal integral minus infinity to infinity. What is N of E? 4 pi by h cube 2 mv star to the power 3 by 2 e to the power 1 by 2 into f of e. F of e is nothing but 1 by 1 plus e to the power e minus ef by 2k. Right? Now we need to simplify this simply. What are the constants you can take it out? Yeah. See, the limits are going from minus infinity to the infinity. Minus infinity means energy levels below, down, down, down. Valence band is there. Further you are going down, down, down. You don't need that. Plus infinity is conduction band is there. You are going even upward. What you need? You need the electrons in conduction band only, no? Not in minus infinity to infinity. Only your conduction band is starting at EC. So remember the conduction band. This is how you are doing now. This is your conduction band starting. Here it is your valency band, VV, EV. So if you go, it will be minus. If you go up, it will be plus. What you need? How many number of electrons are there here? So the conduction band starts from EC. You don't need all these energy levels. From EC to the infinity, because all these are conduction bands only. If you provide more number of temperature, it can go anywhere up. Depends on the temperature. It can go here, it can go here, it can go there. So you need information from EC to infinity, not minus infinity to infinity, really. Because your interest is in the conduction band. Right? So now what I do is, I will modify my integral. I don't need from minus infinity to infinity. The integral will be EC to the infinity, because conduction band is in that limit. So therefore my NC is, instead of minus infinity to infinity, I will write EC to infinity. You should know the reason why you are writing. If you don't know, please ask me one more time. Because we are interested only in the conduction band. Conduction band starts, lower limit starts at EC, upper limit, it can be a limit. So infinity. Then let me write same thing, 4 pi by h cube 2 me star to the power 3 by 2 e power 1 by 2, then 1 by 1 plus e to the power e minus cf by dt. We are doing step by step, more number of steps come. I am not doing everything together. It will get, you will get confused. So now I will take out all the constants outside. So what are the constants? 4 pi is constant. H cube is also constant. 2 me star to the power 3 by 2 is also constant. Integral EC to infinity e to the power 1 by 2 by 1 by 1 plus e to the power e minus ef by dt. Right? Everybody is writing or not? But what is your energy here? You are not interested in all the energies. We are interested in only E minus Cc. Again, for the same reason, because I changed E minus Ec to the infinity, it is the general expression that my state is in the energy electron with the energy. But see, if total is E, if this is my conduction band starting from EC, I want only this information, not total energies, no? Only this information means, how do I write? Total minus
Total minus valency band.
EV should come.
Yes, sir.
E minus EV should come. So that is not the way to understand it. So how do I understand that? Yeah, that's right only. See, Don't get confused. Suppose this is my zeroth energy, let us say. I am taking first, second, third, fourth, E1, E2, E3, like that I went till EC. 0 to EC. I went. I need further. What happens after EC? You know, from here, this is the lower limit, no? That's what, this is the starting point. We need, after this we need. So you subtract total E minus this point. This point means what is this value? EC. You don't want up to there. So you take out E minus EC, what you will get? You will get from here you will get. Are you understanding? Yeah. So this is the lower limit of energies. You are subtracting total energy to the lower limit. If you subtract all these things, you will end up with the conduction band energy only. That is our focus. So instead of E, now I need to take E minus EC. Okay. So let us replace E with E minus EC there. Then how does it modify? How does it modify? NC is equal. Each time you have to put complete values. NC is equal 4 pi by h cube 2 me star to the power 3 by 2 integral EC to the infinity. Then instead of E, we are writing E minus EC. Why we are writing? Because EC is lower limit of the conduction band. So E minus Cc to the power 1 by 2 by 1 by 1 plus e to the power E minus EF by kT. Because it is integral, I missed one point. Because it is integral, you need to differentiate, no? Integral x dx. This is, we are integrating with respect to energy. It should carry dE everywhere. I missed that point. dE everywhere should come. So here also into dE.
Sir, there I will not change, sir. There, e to the power.
Yeah. Here E also can be changed. This is anyway probability. We need not to change. Because what it gives, the probability function again gives, out of these available electrons, what is the probability that it can go to the conduction band only. So the probability function, we need not to change it here. Only here values you need to change. Now, we need to, before solving, we need to simplify this. Because solving this will become complicated. To simplify that, what we do is, the E minus EF term is it positive or negative? E minus EF. E minus EF is positive. Therefore, E minus EF by kT is also becomes positive. And more value compared to 1. E to the power E minus EF by kT is bigger. Therefore, E to the power E minus EF by kT compared to 1. This value becomes greater value compared to 1. So neglect 1. We are simplifying. Therefore, neglect 1 in denominator. If we neglect 1 in the denominator, what happens? NC is equal 4 pi by h cube 2 me star to the power 3 by 2, right? Integral EC to the infinity E minus EC to the power 1 by 2 into 1 by e to the power minus, not minus, plus E minus F by kT to the power dV. I mean differentiation with respect to. Now I will take this denominator to the numerator. What happens?
E power minus
1 by x, 1 by e power x goes to e power minus x. Right? So simply in the next step what I will do is, here I will write e to the power minus of e minus ef by kt. You write in the next step, because of the limitation of the board I am writing here only. Otherwise you will get confused. Do it, man. Not to do it. Do it parallelly, otherwise. Up to here clear for everybody? Now we need to further simplify this. For the simplification, we assume that we will bring x into the picture by simply saying e minus ec as x. Now let us say e minus ec is equal to x. When we change something in the integration, what should change accordingly? Limits should change, right?
yes sir.
So how do the limits change? When I say e minus ec is equal to x,
EC is equal to
limits.
x minus
How the limits will change?
x is equal to EC minus EC is equal to
E is equal to x plus ec.
sir there EC
Limits.
is
Previous limits are ec to infinity, right? So ec to infinity, ec will become what?
x minus E.
E minus x minus
How many of you know how
E minus
limits
x.
change? Don't get confused.
e minus x.
X is e minus ec, right? Your first limit is
EC.
so wherever e is there, you have to keep ec. Ec minus ec. What happens? Your lower limit. Lower limit becomes ec minus ec. Or else lower limit. Lower limit is x becomes lower limit is ec, right? Ec minus ec becomes 0. Upper limit is infinity. So x will go infinity minus ec. Infinity minus ec is nothing but
EC.
infinite minus ec. Kusha,
Infinity.
you are thinking deeply. What is the infinity minus ec? Infinity only. That's the definition of infinity. You cannot subtract, you cannot add anything to the infinity. So ec, even if you subtract, it will become. See, what we are doing here is, you are calling, instead of dE, you want to differentiate in terms of E. So, I mean, differentiate in terms of x. So you change it e minus ec as x. So correspondingly, dE should change as dx, change number 1. Limits also change into the x limits. Previously, e limits are from ec to the infinite. Whose limits? E limits. Energy is varying from ec to infinite. Now instead of energy, you are putting in terms of x. So dE should become dx. Let me write that. So now what is the dx? Dx is equal to ec is constant, it becomes 0. Dx is equal to dE. Dx will become dE, and to change the limits from ec to the infinity, you substitute in the place of e your lower limit, then you will get x lower limit as 0. Upper limit you substitute, you will get infinite as your upper limit. All of you did MPC now, MPC background, still struggling to change the limit. We haven't done this in plus 3, plus 2. We have, right? So now let me modify. My NC now becomes 4 pi by h cube into 2m star to the power 3 by 2. Now the limits I need to write from 0 to infinity. Instead of e minus cc, it will be x to the power 1 by 2 and e to the power minus e. Instead of e, I can write x plus ec minus ef kt into EC is constant, EF is also constant, X is not constant, you are differentiating with respect to. So here constant terms again we have to take it out of the integral. So I am writing it here. So how do I take the constants from that? So NC is equal 4 pi by h cube 2 me star to the power 3 by 2. Okay. Integral 0 to infinity x to the power 1 by 2. Now you have to separate. Constants are e to the power ec minus ef by kt is the constant. Okay. So my constant is, if I split it, e power a plus b, what will happen if I want to split it? What is your name? Viraj. Yeah, e power a plus b is equal e power a plus e power b. Just now, what's your name? Swati is there. E power a plus b. E power a plus e power b. How many hands can I see? E power a into e power b. Remember, it's not plus. Now if you want to split, it is e power minus x by kt into e power minus cc minus ef by kt. So splitting. Plus will not come or minus will not come. Into will come. So if I want to split e power minus x by kt, it is a function of x. It is not constant. Another term is into dot I am keeping into e to the power minus what I have ec minus ef by ec minus ef by kt, and of course I am differentiating with respect to x. So now all x, those are the functions I have, and this is constant. So take that constant also outside. So NC is equal 4 pi by h cube 2 me star to the power 3 by 2. This is the constant term. Bring it outside, e power minus of ec minus ef by kt integral 0 to infinity x to the power 1 by 2 e to the power minus x by kt. Clear? This step is clear?
Sir, there minus will again come now, sir, for AC.
Yes.
Inside also it will come now, sir.
Why will it come? Here minus again will come. It is there now. Yeah. Any doubt is there? If it is not clear, please ask. Back side girls, are you ready? Clear the step or no? Sai Prajwal is there? Second, nobody is there. Veda is absent, no? Today also. What happened? She came and went. Okay, let us come back. We are at the end, almost at the end. Now let us further simplify, because e power minus x by kt looks somewhat TDS. So further simplify by calling, let us say x by kt as y. Okay. X becomes as y into kt. Y into kt. Dx should change as dy because everything, all the x's you are representing in terms of y. So what is dx become? Dx is equal, kt is constant, keep it here, into dy. Accordingly, how does the limit changes? Limits. Lower limit is, it is 0. In the place of x, you have to substitute 0. If you substitute 0, what happens? 0 by kt is 0. So y is also 0, lower limit. And upper limit? Infinity by something, infinity. So basically y is also changing from 0 to infinity, no change. Substitute that. You substitute MC is equal 4 pi by h cube. Every step you have to write this. Some lazy people don't write in the exam, I will not give marks. How to write? Or else you call this some number or something, I don't mind. But it should be reflected. 2m star to the power e by 2 e to the power minus ec minus ef by kt. The integral changes from 0 to infinity. Instead of x, I should write y into kt. Y into kt to the power 1 by 2 e to the power
minus 1.
minus y. Dx means
kt
kt into dy. Kt into dy. Again constants are there in the integral. Here one kt is there, constant. Inside another kt to the power 1 by 2 is there, constant. So kt and kt to the power 1 by 2, what becomes? Kt power 3 by 2. Yes, no? Bring out of the integral. That is our next step. So if we keep the constants outside, don't make noise, just you perform. Bring outside in your notebook. Are you ready? If you bring outside, you are somewhere in that step. Where are you? Huh? Then write where you are talking. So bring kt of 1 by 2 is here. Kt is there. If you add 1 by 2 plus 1 kt to the power 3 by 2, take out of the integral. Therefore your MC is equal 4 pi by h cube. By now you should be knowing this. 3 by 2 e to the power minus cc minus ef by kt. Integral 0 to O. Constant is there, no? Constant is kt to the power 3 by 2. Let us take out as constant kt to the power 3 by 2. After that you perform the integration. You know the integrations anyway. So kt to the power 3 by 2 is another constant is coming out. Then in the integral what is there? 0 to infinity. Y to the power 1 by 2 e power minus y dy. Who knows integrals?
Y to the power 3 by 2.
Solve it. Huh? Correct only, no? So what is the value of this?
1 power 3 by 2 by 2.
Okay, fine. Tell me the answer. Don't do that. If you solve that, what answer you will get? 5 2 pi by 3 or something like that. Why won't be there? You apply the limits. Get me the final answer. What will come? Anyone knows? Get me the final answer. Hey, I asked you to do, not to talk. You confused? That special method only you tell. Okay, we'll use gamma function. So we are using gamma function. What is gamma function is? Gamma function is nothing but this is gamma. 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 So gamma function is gamma of n is equal y power n minus 1. Gamma of n is nothing but 0 to infinity y to the power n minus 1 e to the power minus y dy. This is gamma function. So it is in the form actually y to the power n minus 1. Which minus 1 is that? 1 minus of y to the power 1 minus of e to the power minus y dy. It looks like that. So this is gamma function. You can use gamma function. So instead of this, I can write gamma of it is n or n plus 1. Y to the power 1 by 2 if you want to get, it should be 3 by 2 minus 1. 3 by 2 minus 1. Okay, if you have a gamma function like that, gamma function properties are, gamma function properties are, why are you taking gamma function is, if you know gamma function properties, gamma n plus 1 is equal, the values we know directly, gamma n plus 1 is equal, n into gamma n into gamma n. And it has a value that gamma of 1 by 2 is equal, gamma of 1 by 2 is equal root pi. Gamma of 1 by 2 is equal root pi. You know that. This you know. Okay. Now you write your this function as in terms of gamma function. If you write, what will it become is gamma of what is n? 3 by 2. Gamma of 3 by 2 plus 1 it will become. So gamma of 3 by 2 is nothing but gamma of 1 by 2 plus 1. So total answer should come as root pi by 2. This total value will come as root pi by 2. Root pi is already there. It will add 1 by 2. 1 by 2 extra. Look at our function. Look at our function. You have y power 1 by 2. But you need to have in the form of y power n minus 1. If only you have y power 3 by 2 minus 1, what it becomes? 3 minus 2 by 1. Y power 1 by 2. So your n is now actually 3 by 2. So if you apply gamma function, what you are applying, you have gamma 3 by 2. What is the value of gamma 3 by 2? You should know. That's all. So instead of this, I can write complete thing as gamma of 3 by 2. Gamma 3 by 2 we don't know. We know gamma 1 by 2 as root pi. So what I am doing is gamma 3 by 2 I can write as in this form. 1 by 2 plus 1. If I have this form, n into gamma n, which means
Root pi plus 1.
Sir, 3 by 2 plus 1. 5 by 2 it will come.
what?
1 by 2 into gamma. Gamma 1 by 2.
Hello.
Correct now? n into gamma n. Your n is 1 by 2. 1 by 2 into gamma n. 1 by 2 into what is gamma? So what we are doing, instead of this, we are writing root pi by 2 without actually substituting by simply taking gamma function. Therefore, what we got is, after using gamma function, the value of 0 to infinity y to the power 1 by 2 e to the power minus y dy is root
Minus 1.
pi by 2. Let us substitute there. No, without solving, we use a gamma function. We just carefully look into it. It is easy method because it is new for us. It is confusing, but end value is important. You should remember this. It is the end value is root pi by 2. How we got? By simply taking from the gamma function. This is important. Root pi by 2. If we substitute that, our NC is nothing but 4 pi by h cube 2 me star to the power 3 by 2 e to the power kt is, let me write kt to the power 3 by 2 and e to the power minus ec minus ef by kt into root pi by 2. Root pi by 2. See here, root means it is 1 by 2. Here kt is in 3 by 2. This is also in 3 by 2. Together I put it in under 1 3 by 2. So if I keep everything in the square bracket, it becomes 2 into 2 pi me kt by h square. 2 into 2 pi me kt by h square of 3 by 2 into e to the power minus ec minus ef by kt.
What happened to h cube? H cube no, sir.
H square to the power 3 by 2. 2 will get cancelled. It becomes h cube. We wrote like that. This is h square. Here 1 pi is there. Pi into root pi. What happens? Pi to the power 3 by 2. Pi means pi power 1. Root pi means pi power 1 by 2. 1 plus 1 by 2. So pi power 3 by 2. So pi went inside pi power 3 by 2. 2 me already is there in 3 by 2. KT you already have in 3 by 2. Everything is clear now. So call this total thing as capital NC. So small NC is nothing but capital NC into e to the power minus EC minus CF by KT. This is actually the concentration of electrons equal 2 into 2 pi into m star kT by square to the power. So NC gives the total number of electrons in the conduction band. This is where the derivation was. NC gives the total number of electrons in the conduction band. So any doubt?
Sir, how the 10 plus 1 became 3 by 2? Sir, in gamma function.
Hey, don't stop man. These are in gamma function.
How the 10 plus 1 became 3 by 2, sir?
This one.
Yes, sir. How
So
it became
this
1
is
by
one
2?
known relation. If you have gamma n plus 1, you can write as n into gamma n. This is known relation. Now what you have here? If you use this function, you have like this, no? Gamma 3 by 2 you have. In place of n, you have 3 by 2. Gamma 3 by 2 value we don't know. We know only gamma 1 by 2. So what I am writing 3 by 2, I am writing as 1 by 2 plus 1. If I write 1 by 2 plus 1, see, in the place of n it is 1 by 2. 1 by 2 plus 1. You know this relation. Instead of n, you are writing 1 by 2. 1 by 2 into gamma 1 by 2. But you know what is gamma 1 by 2? Root pi. Root pi into 1 by 2. Root pi by 2. You are using this principle.
Sir, where is root pi by 2?
Uh-huh.
Where is root pi by 2 in the first equation? Above.
Which equation?
The second one.
This equation? Here? Root pi by 2, where is root pi by 2? Okay. Here you have root pi by 2, right? So first you focus on root pi. Root pi means what? 5 to the power 1 by 2, agreed? Here you have 1 more pi.
Root 3
Pi
by 2.
into pi power 1 by 2, what happens?
5
Pi power 3 by 2, right? Here you have pi power 3 by 2. This 2 also went to integral. If you actually solve it, you will get it. So this is very important derivation. It will come for the examination for sure. It will come for the examination.